Question 2D. So we've got these functions here, w of x is equal to e to the x, and we're given the functions now for k of x and k dash of x. And for part one, we need to show that k max is equal to 2 root 3 over 9. So it's the same process as before. We take the derivative, which we're given, and just set it equal to 0. And just going through it as before, multiply both sides by the denominator, then I just get e to the x, 1 minus 2e to the 2x is equal to 0. Divide both sides by e to the x, as that can never equal 0. So this implies then that 1 minus 2e to the 2x is equal to 0. So therefore 2e to the 2x is equal to 1. E to the 2x is equal to half. And you can kind of skip the next step I'm going to do. At the moment, you can take natural log of both sides. So I'll just write it out in full. So it's ln e to the 2x is equal to ln half. And of course, ln e to the 2x is just 2x. You can use the rules of logs to show that cleanly if you want. You just bring the 2x down there and we get ln e, which is just 1. So we can just write 2x is equal to ln half. And therefore, I can actually write this out without the fraction in there. So I'll have ln half, which is equal to ln 1 minus ln 2. ln 1 is just 0, so this is going to equal negative ln 2. So that's 2x, so therefore x is going to equal negative 1 over 2 times ln 2. And I'll just write that out a bit neater without that fraction in front. So it's going to be x is equal to ln 2 to the power of negative half, which is equal to ln 1 over root 2. Okay, so that's the value for x, where the maximum is going to occur. So we'll plug that back in to k of x, and we should end up getting 2 root 3 over 9. Okay, so we'll scroll down, get a bit of room there. Okay, so let's plug it in. So I'm going to get k of ln 1 over root 2. So that's going to equal e to the ln 1 over root 2. So it's getting a little bit messy with all the fractions and things here. Then I get what, 1 plus e, and the function is e to the 2x, so it's e to the 2 times ln 1 over root 2. And all of that is to the power of 3 over 2. And just remember, I'll write it up in blue here. If you have e to the ln x, that is just equal to x. Because remember, ln x is just saying if we raise e to the power of that number, ln x, we get back to x. Okay, so that's a good identity to remember if you have forgotten it. Okay, so going on, then we have e to the ln 1 over root 2 is just going to be 1 over root 2. And again, I'll just write this out for clarity in the bottom because we're asked to show that. So I'll just write out sort of every step here. 2 ln 1 over root 2. Well, that's just e to the ln 1 over root 2 all squared. So that's just ln 1 over 2. And then all of that to the power of 3 over 2. And then that is going to be equal to 1 over root 2. And just using that identity again, e to the ln x is x. I'm going to get in the denominator 1 plus a half to the power of 3 over 2, and you might be thinking already, this looks starting to look exactly the same as the previous part, part C. Okay, so we'll scroll down a bit. So now we're going to get 1 over root 2, and then 3 over 2, all to the power of 3 over 2, which is equal to 1 over root 2. So that's 3 over 2 to the power of a half, and all of that to the power of 3. So that's going to be root 3 over root 2 all cubed, which is 1 over root 2. Then I get 3 root 3 over 2 root 2, and then just multiply by the reciprocal, so 1 over root 2 times 2 root 2 over 3 root 3, which equals to 2 over 3 root 3, and the final answer is that is going to be equal to 2 root 3 over 9 as we rationalize the denominator. So we have shown that. And then for D part 2, now we're asked to say why these are the same. So why does V and W have the same Kmax? So if you remember in part C, V was given by that function lnx and W is e to the x. So basically, there's a couple of ways we could say it. Well, lnx and e to the x are just inverses of each other. So you could actually just state that. You could say W and V are inverse functions of each other. Or you could say something like, well, we know if they're inverse functions, they're going to be reflections of each other in the lines y equal x, and therefore, as they're just reflections of each other, they're going to have the same curvature. Okay, so I'll write a sample sentence down that we could use. Okay, so we can say something like that. The graphs of W and V are reflections of each other in the line y equals x. That'll be fine, it's just worth 1 mark. Or something about that they are inverse functions of each other and therefore sort of equally curved or equal curvature. Okay, so that is part question 2, part D.